Okay, welcome to the third of three videos on Chapter 3. This is, remember, Tuesday, July the 14th. And today we are going to, or in this video, we're going to finish up Chapter 3 and talk about a couple of new things, all right? Those two new things are what we call cumulative frequency and percentile. All right. You may have been, ranked in terms of your class. All right. You fall into the 80th percentile in math and the 90th percentile in English, and so on. All right. How do we actually go about calculating those values? All right. How do we figure out where exactly you belong? Right, this happens to me all the time when I take the triplets to the pediatrician. They tell me that they're in the 30th percentile for weight and the 15th percentile for height and so on. All right. So in order to calculate a percentile, we have to start with a concept called cumulative frequency. Now, this is related to obviously to frequency and to relative frequency, but it's a cumulative thing. All right. In other words, a cumulative frequency is the frequency of all the scores that are at or below a particular score. And so, in other words, you add up all of these scores that are below a certain score, add them to that score, and then divide by the total number of scores. We add this to our frequency distribution tables and symbolize it with the abbreviation CF for cumulative frequency. All right. And so again, in order to compute this, we simply take the simple frequencies for all scores below the score, and we add that to the frequency of the score. All right. So again, to compute a score's cumulative frequency, we add the simple frequencies for all the scores below the score to the frequency for that score. Now, always it's easiest to do this by example. And so let's have a look at a data set that we saw a little bit earlier, although we've changed it around just a wee bit. Now, if you add all of these up, 1 plus 2 is 3, plus 4 is 7, plus 6 is 13, plus 4 is 17, plus 0 is 17, plus 2 is 19, plus 1 is 20. And so my value of n in this particular data set is 20. All right, I think the last time that we looked at this data set, there were no values at 16, and so n was 18 instead of 20. Now, how do we get the cumulative frequency? Well, in this case, it's kind of weird because we are used to working in a table from top to bottom. But in this case, it's actually easiest to go from bottom to top. And so the cumulative frequency for a score of 10 is simply 1. Okay? But the cumulative frequency for a score of 11 is 3. Now, how did I get that? Well, 1, remember, cumulative frequency is all of the scores at or below that score. So add as 2 plus 1 gives me 3. For 12, there's no scores, it's got a 0 frequency. 2 plus 1 is 3, and so the cumulative frequency for 12 is 3. The cumulative frequency for 13 is 7, because 4 plus 2 plus 1 is 7. Okay. The cumulative frequency for 14 is 13, because 6 plus 4 is 10, plus 2 is 12, plus 1 is 13. The cumulative frequency for 15 is 17, because 4 plus 6 is 10, plus 4 is 14, plus 2 is 16, plus 1 is 17. The cumulative frequency for this is 19, and for 17 is 20. Now, an easier way to look at this is simply to add the cumulative frequency for the score below it to the current frequency. So 1 plus 2 is 3. 3 plus 0 is 3. 3 plus 4 is 7. 7 plus 6 is 13. 13 plus 4 is 17. 17 plus 2 is 19. And 19 plus 1 is 20. Notice that the cumulative frequency of the highest score matches the value of n. Okay. Now, a percentile is the percent of all of the scores in the data that are at or below the score. And so if you know the score's cumulative frequency, the formula for finding the percentile is simply the cumulative frequency divided by n times 100. All right, that gives me the percentage. All right. And so that is how a percentile is calculated. So in order to calculate the percentile, the easiest thing to do is to calculate the cumulative frequencies first, divide that by the total number of scores in that frequency distribution to find the n value, and then multiply it by 100. Okay. All right. So let's have a look at the data that we see here. Okay, this is the same chart that we saw a moment ago with the cumulative frequencies on the other side. Now, how do we calculate the percentile here? All right. Well, 1 divided by 20 times 100 is going to be 5. Okay, so that's the 5th percentile. 3 divided by 20 times 100 is 15. This is also obviously 15. 7 divided by 20 is 30 times 100 is 35. 13 divided by 20 times 100 is going to be, 65. 17 divided by 20 times 100 is 85. And then 95. 19 divided by 20 times 100. And then 20 divided by 20 times 100 is 100. All right. And another clue is that this top number, all right, the percentile for the highest score should be in the 100th percentile. It should be 100. Okay. So that's how to calculate a cumulative frequency and a percentile. Now, one of the reasons that we look at percentiles is because the percentile for a given score corresponds to the percent of the total area under the curve that is to the left of the score. Now, obviously, the left of the score is going to be every value that's less than the score. And so a percentile is everything underneath that given or particular score. Now, depending upon what your distribution looks like, you can find different percentiles and different ways to calculate those. But again, the percentile for a given score corresponds to the percent of the total area under the curve to the left of that score. So, for example, this is a normal distribution, and we've seen this distribution of scores before, right? A quiz or a test or whatever it was, where the average was 30, and it was a normal distribution. And so what that means is that 50% of the scores are less than 30, and that's here. 15% are less than 25. And so this area here that you see here is 50% of the curve. And if you, just think about that. It's half of the curve, so it's 50%. Okay. But if we get rid of that and look at just this area, whoops, that's an eraser. That's not helpful. This area here represents 15% of the curve. And then finally, this area from here, all in there, that represents 85% of the curve. All right, actually, I should have included all of this in that mess as well. All right, so all of the stuff that I've just colored in red represents 85% of the area under the curve. All right, and so the percentile is just showing you how many people fit into this data set below you or below a given score. All right, and that's percentiles. Okay, now one more thing before we do some practice examples here. And this is what we call a grouped frequency distribution. Now, group frequency distributions are for when you have a huge amount of data, and rather than calculating the frequency of every single individual score, you kind of pick a small range. So if you're doing test scores, you might choose group 1 to be 0 to 5, and then 6 to 10, and 11 to 15, all the way up to 96 to 100. All right, and so rather than having 100 numbers to calculate frequencies for and that sort of thing, now you've only got 20. All right, because you've grouped them in groups of 5. All right, so 0 to 5, 6 to 10, 41 to 45, 51 to 55, and so on. All right, each of those would represent a group. Okay, and so in a grouped distribution, scores are combined to form small groups, and then we go through and we report on the total frequencies, the relative frequencies, the cumulative frequencies, or percentiles, or maybe sometimes and percentiles. So when you're looking at these things, you're doing exactly the same thing that you would do for a normal distribution or an individual distribution, where you're counting each score and calculating the frequency and relative frequency and cumulative frequency and percentile. But rather than do it 100 times, maybe you only do it 20. Or maybe you even make the groups bigger and therefore have fewer calculations, 1 to 10, 11 to 20. 21 to 30, and so on, all the way up to 100. All right, and that way you're only doing 10 sets of calculations rather than 100 calculations for a given distribution. All right, it just kind of makes things, it kind of makes the data set a little bit more manageable, especially when there are huge amounts of data. All right, and by huge, I'm talking more than 100 scores. All right, some scientific studies have thousands of participants. All right, and in order to do a calculation of this sort to describe the data, you're going to end up with 1,000 calculations. That can be very cumbersome, especially if you're trying to do it by hand. All right, now there are all sorts of tricks with this. You can use an Excel spreadsheet. You can use other statistical programs. Some calculators do statistics for you. But at this point, to do a distribution for individual data points might be a bit difficult. So let's look at the data set that we were looking at a while ago and calculate the various things that we have here. So first thing I'm going to do is I'm going to look at the frequency, the score column. All right, and notice that the scores range from 0 to 44. Okay, and 7 people scored a 0 to 4. 4 people scored 5 to 9. 1 person scored 10 to 14, and so on and so on and so on. Now, another thing that I think would be good to know is the number of scores that I have here. So 2 plus 2 is 4. Plus 3 is 7. Plus 2 is 9. Plus 3 is 13. Plus 1 is 14. Plus 4 is 18. Plus 7 gives me an n equals 25. Okay. Now, the relative frequency. All right. Well, relative frequency in this case here is 7 divided by 25. Now, if you get out your handy dandy little magic number box and you go 7 divided by 25, what do you get? 0.28. So this is the relative frequency here. 4 divided by 25 is 0.16. 1 divided by 25 is 0.04. 2 divided by 25 is 0.08. So these are the relative frequency values. All right, we did this in the first or maybe second video. Now, the cumulative frequency is simply adding the current frequency plus the next. So 7 plus 4 gives me 11. 11 plus 1 gives me 12. 12 plus 4 is 16. 16 plus 2 is 18. 18 plus 3 is 21. 21 plus 0 is 21. 21 plus 2 is 23. And 23 plus 2 is 25. And remember that the total number of data points should equal the top number in the cumulative frequency. Now we calculate the percentiles. All right, this is simply going to be 7 divided by 25 times 100, which is 28. 11 divided by 25. 11 divided by 25 times 100 is 44. 12 divided by 25 times 100 is 48. 16, and so on and so on. So 21, for example, divided by 100. I'm sorry, 21 divided by 25 is 0.84 times 100 is 84, and so on. All right. So that's an example of how you would create a distribution table, not only for a grouped distribution, but for any distribution. Okay. Now, hopefully you'll remember this data set from way back when. We've got 18 data points, so we know for a fact that n equals 18 in this particular case. And so do me a favor, and if you don't have that scrap of paper that you wrote these numbers down on in the previous example, please do so now. But what we're going to do in this case is create ourselves a frequency distribution. Note right off the bat that the highest score is 10, and the lowest score is 10, and the highest score is 17. All of the other data points here give us numbers that are in between 10 and 17. So again, I'll give you a second here to write down these 18 numbers. Okay, hopefully you had enough time. If not, pause the video and go back. So we're going to make our frequency distribution. We're going to start with a score of 17, then 16, 15, 14, 13, 12, 11, and 10 was the lowest score. We'll calculate the frequency. Now, I know that I remember that there was only one 17 and there were no 16s. Okay, I remember that right from the data set. Now, so there's the 17 and there's no 16s here. There are 1, 2, 3, 4 15s. There's 1, 2, 3, 4, 5, 6 14s. There are 1, 2, 3, 4 13s. And then there's only 3 numbers left. There's 112, 111, and 110. So 1, 1, and 1. Now make sure I didn't miss any. I'm just going to add these up to give me my n value. And that's going to give me 1 plus 0 is 1, plus 4 is 5, plus 6 is 11, plus 4 is 15, plus 1 is 16, 1 is 17, 1 is 18. So n equals 18. So I've definitely gotten the correct number. I've counted all my scores. Now, the relative frequency is the next thing that I want to calculate here. All right, now, do you remember how to calculate the relative frequency? Well, it's simply this number divided by, it's simply the frequency divided by n. All right, so in this case, 1 divided by 18 is 0.06. 0 divided by 18 is 0. 4 divided by 18 is 0.22. 6 divided by 18 is 0.33. We already calculated 4 divided by 18. And we already calculated 1 divided by 18. And I'm sorry for the sloppiness here, but again, I'm trying to write this with a mouse. All right, now, in terms of relative frequencies, you want to make sure that these actually add up to 1, okay? So I'm going to do that calculation right quick on my handy-dandy little magic number box. 0.06 plus 0.22 plus 0.33 plus 0.22 plus 0.06 plus 0.06 plus 0.06. And that equals 1.01. All right. Now, remember I said that in some of these cases we're rounding a little bit, and so you may not get exactly 1.00 here, but we're close enough for government work. Now, whoops. Okay, next thing, I want to calculate my cumulative frequency. Now remember, for cumulative frequencies, we're going to start at the bottom and work our way up, okay? And so in this particular example, we're going to start with the frequency for 10, and that score appeared just once. For 11, 1 plus 1 is 2. For 12, 2 plus 1 is 3. For 13, 3 plus 4 is 7. For 14, 7 plus 6 is 13. 13 plus 4 gives me 17 for 15. 17 plus 0 is still 17. All right, and now think about that. That's weird, right? It's got a frequency of 0, but a cumulative frequency of 17. And then finally, 17 plus 1 gives me a cumulative frequency of 18 here, okay? And remember that the cumulative frequency for the highest score should equal n. Now, finally, in this case, I want to calculate the percentile. Now, the percentile, remember, is the cumulative frequency value divided by 18 and then multiplied by 100, okay? So in this case, 1 divided by 18 times 100 is going to be 0.06. I'm sorry, it's going to be 6. Oops. Let me erase that. Back to my pen. And so the percentile is the 6th percentile. Then 2 divided by 18 times 100 is going to be 11. Okay. 3 divided by 18 is going to be 17 times 100. Then 7 divided by 18 is going to give me 39. So I'm up to the 39th percentile now. If I scored 13 on this test, I am in the 39th percentile. Then 13 divided by 18 is going to be 72. So with a score of 14, I'm in the 72nd percentile. with a score of 15, 17 divided by 18, and that should be the 90-something, 94th percentile. I don't have to redo the calculation because 16 has a cumulative frequency of 17 as well. And then, of course, 18 divided by 18 times 100 is 100, okay? And so there's my percentile. So this is a summary of Chapter 3, given the data that we had. Now, all right. So with that, let's ask ourselves a couple of questions here. As we saw on slide 8, the simplest frequency table for this set of data is shown at the right, all right, and there it is. All right, if you look at this, the table, this just shows the first 2 columns, but it's exactly the same as the first 2 columns that we've drawn here, right? The scores range from 17 at the top to 10 at the bottom, and the frequencies are listed next to them. All right, so there it is. Now, just a quick question, all right? We can see from this table that the frequency of the score 12, so here's 12, is 1, okay? And we know that the total number here is 18, because again, 1 plus 0 is 1, plus 4 is 5, plus 6 is 11, 15, 16, 17, 18. So n equals 18. All right, and so that's our that's easy peasy, right? The simply determining frequencies and the value of n. Now, the relative frequency of 12 in this data set is going to be the frequency, which we calculated as 1, divided by n, which is 18, and that's going to give me 0.06. So the relative frequency of 12 in this data set. Let's go back. Here's 12. Here's the relative frequency. Oh, look at that. It's the same number. Yay. All right. It'd be bad if it wasn't the same number. Okay, but there it is. That's the relative frequency of 12 in this particular data set. Okay. And that's how we calculate it, right? The relative frequency of 12 in this data set is frequency 1 over n, 18. And that gives me 0.06. Now, what's the cumulative frequency for a score of 14? All right, well, the cumulative frequency of 14 is the frequency of all the scores at or below 14 in this data set. So this is the frequency of 10, this is the frequency of 11, this is the frequency of 12, this is the frequency of 13, and this is the frequency of 14, okay? We can go back and check that in a second, but if you add them up, 1 plus 1, all right, you know what, we'll just go back. 1 plus 1 plus 1 is 3. I don't know what's going on here. There we go. 1 plus 1 plus 1 is 3, plus 4 is 7, plus 6 is 13, okay? And this is the data that we're looking for, okay? And so the cumulative frequency is 13, all right? So there we are. Now, if we go back and look at our data set, the cumulative frequency, come on, cumulative frequency of 14 is, look at that, same number, okay, 13. So that's the cumulative frequency of this. I'm sorry for all the bouncing back and forth. This would be much easier if I had a blackboard in a classroom and was trying to do it that way. Okay, now, what is the percentile for a score of 14? All right, well, the percentile of 14 is the percentage of all the scores that are at or below 14 in this data set. And so now they used an extra data or decimal point here. All right, I rounded these numbers. Come on! This is 0.6 plus 0.6 plus 0.6 plus 0.22 plus 0.33, and that gave me the value of 0.72. Okay, so here's the cumulative frequency that we calculated in the previous slide. That's 13 divided by n, which is 18. And so this is the percentile. Now, remember that you have to multiply this by 100. And so this is actually the cumulative frequency, 0.72. The percentile is 72. All right, now let's go back and look at this. And so here's 14. All right, the cumulative frequency is 13 divided by 18 gives me 0.72 times 100 is 72. And so that's the same number as well. All right. Again, I'm very sorry for all the flipping back and forth with this. This is much easier to teach in a classroom with a blackboard or a whiteboard, but we're doing this from home, so I'm trying to do the best that I can. All right. So that is then that. All right. And so that ends the third of 3 videos on chapter 3 here. And I hope you learned something. Don't forget that you have a homework assignment due on Thursday on chapter 3. All right. The application questions at the end of chapter 3.